Using remotes to control various appliances in your home is nowadays very common. Infrared LEDs, IR receivers and a unique communication protocol like NEC makes it all possible. But once you lose such a remote, you usually don't have access to the necessary IR codes and have to control your device by hand, which is a pain in the ass. So in this video I will show you how I added an additional circuit to my speaker system in order to control it with a homemade remote. Let's get started. First off, I removed the front panel of the subwoofer units, unplugged the connection cable, unscrewed the 4 visible screws on the PCB and sliced through the foam on the sides in order to free the control PCB. The important components are the Atmel AT89 microcontroller, the 3 tactile switches and the IR receiver. By following the circuit paths of the switches and doing some continuity testing, I asserted that by closing the switches, they connect different inputs of the microcontroller to ground. This can externally be simulated through the help of NPN bipolar transistors, like the BC637. I simply added a gate resistor of 2 kΩ to each of them, which also connect to the Arduino Nano pins 2, 3 and 4. Then I connected their emitters to the ground potential of the control board switches as well as the ground pin of the Arduino and hooked up each individual collector to the other side of the switches. By creating a simple test code, I turned on each transistor one after the other, which seemed to achieve my intended goal by simulating the tactile switches I had to push by hand before. So I moved on by adding an IR receiver, the TSOP4838, to the mix, whose output pin directly connects to pin 11 of the Arduino. Afterwards I included the IR remote library in the code, used the command to capture incoming IR signals and used 3 random 32-bit hexadecimal values as trigger values to activate the transistors. And at this point the receiver was complete. Time to move on to the transmitter. For that I used an Arduino Pro Mini with sorted in headers and 3 tactile switches with pull down resistors on pin 4, 5 and 6 that can connect the input pins to the supply voltage. Additionally, I used an IR LED with a 100 ohm resistor on pin 3 of the Arduino. This setup should illuminate the LED bright enough at a voltage of 3 volts, since I will be using a 3 volt button cell as the supply voltage later on. After creating the transmitter codes, which sends out the previously chosen hexadecimal values by pushing the tactile switches, I uploaded the code with an FTDI breakout and did another test, which turned out to be a success as well. But one problem that still remained was the power consumption of the transmitter, which was around 8 mA at 3 volts. Which means that a common button cell with a capacity of 220 mAh would only last around 27.5 hours. To save a bit of power, I desoldered the indicator LEDs of the Arduino as well as the super tiny 5-pin voltage regulator. This resulted in a current consumption of around 7 mA, which was still too high. So I included the low power library in the code, added another tactile switch with pull down resistor on pin 2 and edited the code slightly so that the Arduino enters sleep mode after 3 seconds when no button was pushed. Afterwards only the wake up button can wake him up and resets the timer for the next sleep session simultaneously. And during sleep mode the Arduino only requires a current draw of below 1 microamp, which allows a battery runtime of a couple of years. Perfect! As a last necessary test, I disconnected the so far used IR receiver and tried hooking up the output pin of the already existing receiver of the speaker system to the Arduino, which worked just as well. But instead of the Arduino Nano, I will be using an Atmega 3208P later on, which I programmed beforehand with an Arduino Uno. But don't worry if you're confused now about how to implement this IC, because I drew an easy to recreate schematic for the final design of the receiver and transmitter with the help of the Easy EDA circuit design software. You can find those schematics, a parts list and additional information about this project as always in the video description. But nevertheless, I then started the circuit building process with the transmitter by creating a 10 by 15 cm square of perf board with copper dots, determined a logical layout for the components, and sawed in one after the other before I finally connected them with silver copper wire and a bit of flexible wire. After plugging in the battery, the circuit worked just fine. So I created another piece of perf boards according to the size of the control boards and created my receiver circuits by following my previously drawn schematic. At the end of this project, I drilled 4 holes into the perf boards with the control board as a reference, cut 4 small pieces of M3 threaded rods, connected the supply voltage, the switches and the IR receiver outputs of the control ports to the perf board and fixed everything in place with the help of the threaded rod pieces and 4 additional 2 cm spacers. After screwing in the front plates and testing out the final results, this project was finally complete and works like a charm as well. I hope you liked it. If so, don't forget to like, share and subscribe. Consider supporting me through Patreon, that is what keeps the show going. Stay creative and I will see you next time.